Hey everyone, welcome back to my channel EduVibe. Today we will start with another topic of grade 12 physics or for the unit momentum and the impulse, which is force time graph. As I told you when we do the impulse lesson that we are dealing with impulse more in this unit than the momentum. We'll use momentum, but later on videos we will use more momentum and impulse both also. So, but in today's video, we'll more focus on a change in momentum. The change in momentum, you all know that is the impulse. So, impulse is more related with the force time graphs. So, we'll do the velocity time graphs, position time graph in kinematics in grade 11 physics. But today we will focus on the force time graphs. Force time graph is more likely when we do the displacement graphs. When we calculate displacement from the graph, is like a similarity in the impulse and displacement. We'll do the force and the time if we have force time graph, so we can find the change in momentum in anything. We get the net impulse from there. So how can we deal with? Firstly, we start with some thing which we have to know about this. Then we do the example for this. So if the net force is constant, we will do the net force is not net force is always constant when we're dealing in the impulse calculations. But today we will focus on the when net force is not constant. There is in like a state where that is not constant. So we can use a force time graph to determine the impulse. If the question they mentioned that the net force is not constant, so we have to use the force time graphs to calculate the impulse change in momentum. So here's we have a graph of force time graph. This is the force and this is the time. Force is on the y-axis, time is on the x-axis. And when we have like this type of thing on the upper hand in the positive, in positive way, so we have a positive impulse in this. If we have something in over there, so this is the negative, so we take with the negative impulse. So the area between the graph line, this was your graph line, and the horizontal time axis, which is this line, horizontal time axis, all the force time graph yields the impulse. This will give you the impulse when we calculate the area between. When we calculate this thing, we will get the impulse from there. Area above the TSS, so the above the TSS we have a positive impulse, as I told you. If below the TSS we have a negative impulse, this one. So when we combine in all the areas, when we combine all the areas which we have in force time graph and which they have the range of this, so we'll give the net impulse on an object. So we'll give the net impulse from their change in momentum from here. So that's how the force time graph works with the impulse which is change in momentum. So let's deal with the example for this. We have a graph of force time graph. Force is our south and this was our time in seconds. So the question says that the graph below shows the force experienced by a soccer ball during the game before and after the kick by a player. So the soccer ball experienced by the before and after kick ball. We will determine the impulse experienced by a soccer ball during the cricket. So this was the graph which we have to know that this is the thing which we have to find, this area we have to find. So to find this area, we have to find this. So this is a change in momentum which we have to find. And this is a kind of a triangle. Area is half into base into height. So half, and you don't know the base or height, so we have to get from the this triangle. So from here to here is your height, which you calculate from the 60.00 to 0.0. So it's 60.0. This is your height. So when you do 60.0 minus 0.0, you get 60.0 seconds. This is your height. And for base is from here to here. This is from 3.00 to 7.00. So you do 7.00 minus 3.00, you get about 4.00. But the time is into 10 raised to minus 1 2. There's a missing over there. So this is 10 raised to minus 1. So you have to multiply this 4.0 with 10 raised to minus 1 seconds. So this is your time and this is your force, and force is always in south. So they mention that this is the south, this goes up. So we take south as positive because we haven't only have south. So we treat it south as positive. We have a base of 4.00 into 10 raised to power minus 1 seconds, height of 60.0 newtons. So by multiplying this all thing, you will get about 12 Newton second. This is in a south. So that's how you can find the net impulse. This is a simple triangle. There's only one triangle. There's not like a parts of this, but you will get the parts for this too in the examination or in the diploma. We will deal with those examples too, but in the practice question session when we'll do the practice questions. So next question is like all are related with this B part. So the mentioned soccer ball initially traveling the 5.0 meter per second north. After the kick, the ball traveled 20.0 meter per second south. Determine the mass of this. We have 5.0 meter per second, which is our VI, was initially at this, and then you have the south. This is our north, so we take south as positive in the A part, so we take positive in this, so north is negative. After that, when after the kick, so it's in 20.0 meter per second, so this is your final velocity. So now you have to find the initial and final you have. So you have a change in momentum too. I mean, there, this is a change in momentum. So, so we have mass delta V. So we have to find the mass from here. To find mass, we isolate the mass. We get change in momentum on delta V. So mass is equal to change in momentum is 12 Newton per second. You find in part A that delta V is Vf minus Vi. So from here Vf is 20.0 meter per second, negative, you minus it by minus 5.0 because this is in north and we take north as negative. When you solve this, you get mass like 12 Newton upon 25 meter per second. When you solve this, you get about 0.48 kgs. So this is your mass of the soccer ball. This is 0.48 kgs. So that's how you can deal with the force time graphs and to find the change in momentum, which is your impulse. We will do more questions in practice questions when we're done with the first half of this unit. So learning is simple with EduVibe. Learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions related to this topic, let me in the comment section. We will start with the another topic of this unit, which is like a more practical unit, which we have to do the long calculations. So see you in the next lesson. Till then, stay connected with EduVibe.